There we go. Okay, so anybody need to ask me about 6 through to 9? I think page 10 is on this page as well, isn't it? Ooh, 6 through to 11. So there's 6 through 9. There is 10 and 11. Does anybody wish to ask about any of them? Going once. Just curious. Can I do 10? Yes, certainly. So I'm going to deal with the exponent first. So that is going to be the 4 goes to everything inside the bracket. So negative 2 to the 4th power is positive 16. Yes. A to the 4th, B to the 8th over 2. Now the bottom here gets weird because it's A to the 6th, B to the 3rd, because that 2 doesn't get the exponent because it's not got a bracket. It's not part of the base. Then I like to split them up like this. So 16 divided by 2, there's my 8. 4 minus 6 is negative 2, right? So the A's would have been negative 2, and 8 minus 3 would have been B to the positive 5. Sorry, I've crammed that together there. Let me just move that. Let me just move this. See, now that my pen's working, I'm doing all kinds of stuff with it, just for the heck of it. This, of course, got me A to the negative 2 and B, 8 minus 3, positive 5. What there isn't allowed? Just the negative 2 part. Now, of course, my pen is frozen. So it will go down to the denominator. Okay? Everybody good with 9 through 11 or 6 through 11? Sure. These are not the same base, yes? Everyone agrees? But isn't 4 2 squared? Right? And isn't 8 2 cubed? And isn't 16 2 to the 4th? So it's really 2 squared to the x, isn't it? And 2 cubed to the x plus 4, isn't it? And 2 to the 4th to the x plus 1, right? Then what do you do over exponents? What do you do over brackets? Multiply. So that becomes 2 to the 2x, right? Times 2 to the 3x plus 12, right? Over 2 to the 4x plus 1, or plus 4, right? And now, is this the same base? And what math is happening right there? Multiply. What do we do with exponents when we multiply? Add. So 2x and 3x, that's 2 to the 5x plus 12, yeah? Over 2 to the 4x plus 4. Are these the same base? What math is happening here? Division. What do you do with exponents when you divide? Subtract. 5x minus 4x is 1x. 12 minus 4 is 8. Now, if we had video of Friday, I would have gone back to it right now and stopped it and paused it at the part where I say, it doesn't matter what exponents look like. The exponent laws apply to everything. Does everybody remember me saying that on Friday? Right. So it doesn't matter that these look weird. It's just the same stuff that you already know how to do. Okay? Don't be fooled by looks. Everybody cool? All right. And then the next page was pretty easy, pretty much easier. There is down to number 8. Please check your work over. Now, normally, guys, this would have been posted on the YouTube video, and you could have checked it there. But everything was messed up on Friday, so that couldn't have happened. That's why we're using a lot of class time right now. Again, If you are writing down all of this right now because you did no homework, normally that wouldn't be a problem because normally you'd be doing it on your own time on YouTube. And again, writing it down is better than not having it at all. Since just about everything in Exponents is review from the 10th, 9th, and 10th grades, I will not be doing any quizzes for this first little unit. This will be your practice. We will write a small test on Exponents in a little while. When exactly, I do not know. But expect it this week. Okay? Is this a day 1 Friday? Does anyone know? This Friday will be a day 2. Let us check on the Panther Planner app, because I love using the Panther Planner app, as should all of you. Tuesday, Wednesday, Thursday. Oh, something's happening on Wednesday that I did not know about. Oh no, that's next week. I'm on this the wrong week. What a moron. It's a day 2, which would mean you guys were in this class second block Friday. So you would not be remiss in expecting the possibility of a small test on Exponents on Friday, because it's not first block. I normally don't like to give tests on Fridays if I can avoid it, but because it is such a small test, and because you were in here in second block and already have a block to turn your brains on, I don't feel as bad as I normally would. Okay. Okay. Any questions about 1 through 8? 2. Okay. Should I care about that negative sign? Yes or no? Why? It, not always, but you need to be aware that that negative applies, might very well apply at the end. Yes? Okay. So, but since it's outside of brackets, it's not part of a base, we can worry about it later. We need to worry right away about our exponents. There's a V, there's a V. What math is happening between them? Multiply. So what do I do with the? I add them. 1 and 4 is V to the 5th. Cool? All right. What's happening here? One moment. Uh-huh. Find a desk. There has to be a desk. There's one right there. There's only 30 kids in the class. There's 30 desks. What is happening with the green highlighted guys? Adding 3 plus -2 is 1, yes? Okay. So we've dealt with all our exponents. Then we got to do 3 times 2, which is what? 6. Then I worry about the negative. When would you not worry about the negative? If I had something like this, -3x squared, would I worry about that negative? Why? Because it's a bracket, it's in the base, and as soon as we square it, what's going to happen to it? What happens to a negative when it gets squared? It becomes positive, right? That's where you got to be careful. That's where we like to mess with your heads. This, -3x squared, is not the same as this. Okay? All right. Any questions on 3, 4, 5, 6, 7, or 8? 7. Negative out in front, right? So you can leave it there. I usually just move it up to the numerator for my own thinking purposes, right? The whole answer's got to be negative. So the 5 and 4 I like to split it up. Numbers with numbers. Do 5 and 4 change? Nope. Letters with letters. X to the 1 over x to the 4th. That's going to get me x to the negative 3, right? Nothing up top and a y to the 4th in the denominator. So that's technically y to the negative 4, isn't it? Negative exponents aren't allowed, so they go down to the denominator and they are positive. Okay. And 9 to 12. Anything there? Yes. Split it up. Negative 3 over negative 3. Same thing on top, same thing on the bottom, so they cancel out because they're number 1. Yes? X and x to the negative 1. That's 1 minus negative 1. Yes? What is 1 minus negative 1? 2. So I have x squared, so I don't have to move them. And I have y over y. What happens there? Same thing that happened with the negative 3s. They cancel and become 1. So what was the only thing I had left? X to the positive 2. Gouda? Yes, I can. So, nothing's changing up top, right? 2x, y, negative 1. On the bottom, that negative 1 has to go inside the brackets, yes? So I'm going to get negative y to the negative 1, and I'm going to get x to the what? What's negative 1 times negative 1? Positive 1. Excellent. And then I also had down there 2x squared y. Now notice I changed the order. That's just because I like having x's first. It's the same thing, right? Okay. What's the number that should be right here in front of y that we don't write? 1. Excellent. So what's negative 1 times 2? Negative 2 on the bottom, yes. And negative 1 plus 1. Because this should have an exponent of 1, right? What's negative 1 plus 1? 0. So do we need y on the bottom? No. And what's 1 plus 2? X cubed, right? That's the bottom. The top is 2x, forgot that squared right there, 2x squared y to the minus 1, right? Okay, split it up, numbers with numbers. What's 2 divided by negative 2? Negative 1, got it right there, yes? X squared divided by x cubed. That is x to the 2 minus 3, yes? Which is x to the negative 1. Is that allowed? No. So down to the denominator, there it is. And y had a negative 1, so where does it have to go? Down to the denominator. I can't stress this enough, guys. You cannot, until you're really, really, really good with exponents, you have to show work. You have to do your steps. You have to. And if you do each law, it's only a matter of knowing 1 or 2 things per question, right? All right. Everybody good? All right. You had the answers to the next 4 pages. They're all in your book on page 11. So you can check your own work. When I give you work time today, if you haven't finished those pages, you can do them. Or when you check them over and you need assistance, you can flag me down while I'm walking around the class, okay? Okay. So let's zip up to page 12, please. Rational exponents. Now remember, I talked about this on the very first day. Is that big enough, or should I make it 1 click bigger? 1 bigger would be better? That was fun to say. 1 bigger would be better. It's like a tongue twister. Better? Okay. As I was saying on the very, very first day, in real math, we use the real words. And rational, we remember a rational number is a number in that form. So rational exponents, you guys are going to say, what you're going to say to yourself most likely is fraction exponents. I'm still writing. The word will show up in a minute. Okay? In reality, they're called rational exponents. There it is. Everybody good? Okay. You already know this from the 10th grade. A great many of you know this from the 10th grade. If you don't remember it from the 10th grade, then, of course, you were going to relearn it right now. I do say to use your calculator to do this operation right here. Now remember, on your calculator, up to grade 11, we were often evaluating, weren't we? We were trying to find an actual answer. Then up to grade 10, I mean. In grade 10, we started leaving stuff, like x to the 7th. That's the answer. You don't actually know what it is because you don't know what x is. So when we were evaluating something like this, if we were evaluating 9 squared on our calculator, which we of course know is 81, on our calculator, we had to go 9, and then we had to hit a button. Most calculators say x to the y, some say y to the x, some have the little caret symbol, like a little mountain. Some have x with a little blank square over it. That's your exponent button, okay? You all know how to use it because you've all been through grade 10. So you would have 9x to the y2, hit equals, and you would have gotten 81. Well, now we want to do that with fractions. So most of you, a lot of you, probably remember these 3 answers, but if you don't, no big deal. We'll do it right now. So you're going to get out your calculator, and I want 9 to the 1/2. So you're still going to hit 9, because that's your base. Then you're going to hit your exponent button. And then you need the fraction. Now, if it's a fraction that works, like 1/2, you're just going to go 0.5, right? 0.5, and you're going to get an answer. And of course, you don't need to get out your calculator because you've all done this before, right? I would be much happier if you got your calculator out for the middle one. So this first one I'm not going to waste a lot of time with because it works so perfectly. 9 x to the y, 0.5, enter. Oh, and it's 3. Okay, you all knew that. You all remember that. It's 3. Now the reason I said I wanted you to check out your calculator for the middle one is because 1/3 isn't a decimal that works very well on our calculator, is it? So you don't want to hit 0.33333 1,000 times. So to do fractions that don't work out, they give you a repeating decimal, then you got to still do the base, you still do the x to the y button, then you do bracket, 1 divided by 3, close brackets, then equals. Everybody do that one. Even though you know the answer, make sure you can get your calculator to give it to you. Because everybody's calculator is slightly different. And it's a real pain in the butt for math teachers because 29 kids out of 30 make their calculator do the right thing and one kid is always like, mine doesn't do it. So we got to figure out what kind of calculator that kid has. So if everybody would be so kind as to try to make this work. And of course, if you don't remember, the answer is 27 bracket 1 divided by 3. Close brackets. Enter. It is, of course, 3 again. Everybody cool? Everybody was able to make a calculator do that? Okay, and the last one, check it. What is it when you punch it into your calculator? What is it? 5. Absolutely right. Now, that should tell you something. 9 to the 1/2 is 3, right? Okay. What else do we know about a relationship between 9, 3, and an exponent with a 2 in it? Right. 3 squared equals 2. 3 squared equals 9, yes? Right? Which means the square root of 9 is 3, yes? If the square root of 9 is 3 and 9 to the 1/2 is 3, what does that tell us about the square root of 9 and the answer to 9 to the 1/2? They're the same thing. They must equal each other. Everyone is aware of that piece of logic, yes? If A equals B and A equals C, then B equals C, right? Okay. So that should tell you something. This symbol right here, which we're going to be reviewing in the next unit, is not written properly, is it? What is technically missing from that notation? It should have a power of 1, shouldn't it, Sukhpal? Because everything has a power of 1, doesn't it? We just don't write it down. So this really has an exponent of 1, doesn't it? Right? What else is missing from this construction? A 2. Where should that 2 be? It should be right there. It's the index number. So once you see this written properly, that should remind you of what this actually means. The base over here becomes the radicand in here. The denominator becomes the index, and the numerator becomes the power. So when we get to this situation here, we should be able to rewrite it and figure it out without a calculator, shouldn't we? What happens to that little 2? It becomes the index. So I'm looking for a square root of something. What happens to that little 3? It becomes an exponent. So I'm going to cube that. What happens to the base here? It becomes the radicand in here. Now I'm going to do something a little funky. Why did I do that? Why did I turn 0.04 into that? Because it's the same thing, isn't it? It's 400ths, right? And I did that for a reason too. Because it allows me to show you a quick shortcut. What is the square root of 4? 2. What's the square root of 100? 10. So this is really 2/10 cubed, isn't it? Right? But is 2/10 something else? That's 1/5 cubed, isn't it? And what do we know about exponents outside of brackets when there's a fraction involved? Where does that exponent go? Top and bottom. So what do I really have here, Sonia? 1 to the power of 3, which is 1, and 1/5 cubed, which is 1/125. Right? Everybody good? Okay. Now the reason I showed you this is because I want you guys to recognize something. And don't write down what I'm about to do. Just look. Square root of 4 is what? 2. Excellent. Square root of 0.04, right? What would that be? 0.2. Absolutely correct. Square root of 0.004. What's that? Talk to your neighbor if you need to. So Max says is guessing 0.02. Why are you guessing that, Max?
Well, the other ones followed the same order.
4, 2, 0.04, 0.2 makes good sense, right? Look how many decimal places you got there. How many decimal places are in this one? 3. So that's 4 over 1,000, yes? Right? 4 has a square root, but does 1,000? No. So this one you can't do. It's irrational. So what are you saying, Myers? Well, I'm saying, what do you think then is 0.0004? What's that one when it pops up? Because it's going to take a second. I'm going to have a sip of my coffee. First, it's going to be not responding. Then it's going to come back. Then it's going to put the numbers in. What's that guy? Now say it, Max. Now say 0.02. Absolutely right. Why? That's 4 over 10,000, right? Square root of 4 is 2. Square root of 10,000 is 100. 2 over 100 is 0.02. The reason I put that into fractions is to remind you of a quick shortcut. If it's got even number of decimals, you can often get a square root for it. But an odd number of decimals, you can't. Everybody good? All right, let's have a look at this guy. What do we know about this construction? Where will the 3 go? Index. Where will the 27 go? Radicand, that's what we call that guy, and it will be to the 4th power. What is the cube root of 27? I don't know, Mr. Myers, I don't know how to do that. You do. We'll be reviewing it next unit in case you've forgotten. But it is 3 to the 4th power. What do we do there? We use our calculator or we memorize it. It is 81. Everybody cool? Review, no big deal. Now we start applying the stuff that we already have reviewed earlier in the year. This looks weird, yes? But is it weird? Isn't this just some number to an exponent all to another exponent? And what would we do with the a and b if there weren't any fraction or anything funky involved? What would we do with a and b? Multiply them. So what are we going to do here? Multiply them. What's 1/3 times 2? It's not a trick question. 1/3 times 2. Anyone? Loud and proud. This pen is 1/3. If I have 2 of them, how many thirds do I have? 2/3. I know, it was complicated. It's early still. You thought I was messing with you, but I wasn't. I was just doing 1/3 times 2. So that is 8 to the 2/3. Now we can deal with it, yes? Cubed root of what? 8 to what power? He waited patiently. 2, because we have a new numerator. What is the cube root of 8? 2. What is 2 squared? 4. Everybody cool? Is anything new happening? Have we done anything new? No. We have changed the way things look. All right, let's look at D. Couple of ways we can do that. When I look at D, as soon as I see that 2, I know I'm looking for a square root, right? And I see that it's a decimal, yes? Does it have 2 decimal places? So is it possible it has a square root? Sure it is. What would the square root of 49 be? 7. But I don't need the square root of 49 and square root of 0.49. So I must need how many decimal places in my answer? 1. because I had 2 here, right, Burke? So when I square root, I'm going to lose one of those decimal places. So this is going to be 0.7. To what power? 1. Do we ever write it? No. Now when I write that, it's because I did it in my head. If you're not really getting it, then what is really happening here? This is really the square root of 49 over 100 all to the first power, because these are the same thing, aren't they? The square root of 49 is 7. The square root of 100 is 10. So I have 7/10 to the first power, which of course you all know is the same as 0.7. Right? Okay, look at E for a moment, because E looks weird. What's weird about E? It's a decimal exponent. Wait a minute, Myers, you haven't taught us anything about decimal exponents. But I have, because this isn't a decimal exponent, just another way of writing a rational number. And isn't every rational number something we can write as a fraction? Great. So how would I write 1½ as a fraction? 3 over 2. Because this is 1 1/2. Still not a fraction, is it? Then I convert it by doing the trick we learned in grade 4 with Mrs. Bad Crumble. Multiply plus 2 times 1 is 2 plus 1 is 3, yes? So I really have 16 to the 3/2. Now, super easy. What am I looking for? Square root of 16 to the 3rd power. What is the square root of 16? 4 to the 3rd power. What is 4 to the 3rd power? I don't know, Myers, so what do? You get out your calculator and you know that it is 64. Everybody cool? Okay, what's happening over here? Anything new? 0.75 isn't something we can work with, is it? But 0.75 does become a fraction. What? 75 over 100. It's a pretty big number. Can we make it smaller? 3/4. 81 to the 75 over 100. Absolutely correct. Luke says 75 over 100. And then he says, wait a minute, I don't want to find the 100th root of something to the 75th power. So he simplifies that fraction to 81 to the 3/4. And now he's looking for the 4th root of 81 cubed. That's 3 cubed. And that's 27. Is everybody cool with the basics? Great. Now what happens if it doesn't work? So I'm looking here for the 5th root of 8 squared, yes? Everyone agrees? You guys aren't stupid. There's no 5th root of 8, is there? There is no number that can multiply by itself 5 times to get to 8. So this is an important piece of information for you. You guys, high school math kids don't like these situations. You don't like it when you can't get an answer from your calculator. It bugs you. Because if you were to punch this into your calculator, your whole screen would fill up with decimals, right? And when your whole screen fills up with decimals, what do you know has probably happened? That decimal has continued on. If your screen stretched out to infinity, how full would it be? If it was an irrational number. How many decimal places do irrational numbers have? Pardon? They don't end. So we can't do this with our calculator. So this is where you guys go a little crazy sometimes. Not crazy, it bugs you. This is what we call an exact answer. And it bugs you because it's not an answer, is it? You guys want an answer. You want your calculator to do something for you. So if you are faced with finding something exactly and you end up with irrational numbers, this is how you have to leave it. Everybody cool? Sometimes, and you'll do that in math. In physics, that number means nothing, does it? How fast do I need to make this thing go? Well, you got to make it go the 5th root of 8 squared. Does that mean anything to you in a physics classroom? No. So in a lot of other disciplines, you're going to actually have to find a value here. But will it be an actual value? Or will it be an approximation? Well, get out your calculator and check. How do I put that into my calculator? 8 exponent bracket 2 divided by 5. Close brackets. Barf. My screen filled up. Irrational number. So that becomes our estimated value. And that's when you get the question, oh, how many decimal places? And it was like 2.29 something, right? 2.297. Everybody cool with that? Depending on what you're being asked for, that's going to define how you answer it. Okay? Now, if I ask you over here, what are the 3 ways I could write an answer to this question? There's 3 things you could do. Somebody give me one of them. Or I can sit here for a while. I got time. Oh, Luke.
Yeah, can you do 7 and square root 6 over 10 to the power of 15?
That is perfect, Luke. That's the one I didn't think anyone was going to say, and that's the one you said. Nice work. Could you leave it as a decimal? Yep. You could also write 7.6 to the 15th. And the last thing you could do is give me the estimated value. How are you going to put that into your calculator? Same way we've done it all the way along. 0.6, exponent button, bracket, 15 divided by 7, close bracket. Does anybody have a value for that? Pardon? 0.335. Thank you, Sid Paul. 0.335. Everybody good? All right. I'm not going to do these 3. I'm going to ask you to do them yourselves, but not right now. I'm just going to point something out to you. The formula is this. The m is the mass. So where does that 27 go? It goes right there, right? Now remember to do bed mass properly. Are you going to do 27 to the 2/3, or are you going to hit 0.1 first in your calculator? 0.01, I mean. What's the first thing you got to do in this question? What do you got to do first, according to the rules that you learned in the 8th grade? Brackets. There aren't any brackets there, because I put brackets around 27. Those aren't math brackets, are they? I got to do the exponent first. So when you punch this into your calculator, you got to make sure you do this part first. Cool? I'm going to leave you guys with that so we can get moving. Simplify. Please notice I've asked you to do these without a calculator. And I've only asked you to simplify. So, am I ever if there's letters involved looking for an answer? No, because we can't, can we? So look at this. It looks weird. When I write it out, you guys are going to say, oh, it looks weird. I don't know what to do with it. But you do know what to do with it, because what do you see there and there? Same base, which means what do we do with the exponents? Add them. What's 5 minus 3? 2. So what I've got there is 0.3 squared, yes? I'm going to ask Luke, 0.3, that's a real easy number to square. What's 3 squared? 9. And what's 1/10 squared? Right, it's going to be 0.09 because I need a second decimal place. Do it without our calculator, no problem. This one is a problem, though. How many people look at 2 and just for a little second are a little scared of it? Be honest. Nobody? Great, what's the answer? Go. Come on, Akshay, you weren't scared of it. What is it? You were a little scared of it, weren't you? Yeah. Do you need to be scared of any math? No, it's not a shark. It will not swim up under your surfboard and bite off your arm like that surfer girl in that movie. You know what to do with it. What if this was an X? It would be easy, wouldn't it? What do we do over brackets? With exponents. Multiply. So this is to the -8, isn't it? I'm going to go ahead and I'm just going to write that as X. Is everyone okay with that? Now, since I wrote that as X, isn't that the same thing? Okay. Why am I doing that? Burke, are you making a face because you don't know why I'm doing that? Okay. What looks easier for you? X squared or -7/5 squared? The X is easier, yeah? So I'm going to go ahead, and I just made these both X's because they're the same base, aren't they? Okay, so this, what do I do over the brackets? Multiply. So this is going to be X to the 6th, yes? Are these the same base? They are, aren't they? What do I do with the exponents then? Add them. What's -8 plus 6? -2. So what I really have here is X to the -2, don't I? Right? But I don't have X. What do I really have? -3 halves to the -2. What does a negative exponent do to fractions? Flip it over. So what's that going to become? 2/3? To what power? You guys are almost perfect. What did I do with that thing that I shouldn't have done over here? Do I still need that negative? Yeah. This is -2/3 squared. But is that negative part of the base? Is it? And is it getting squared? So what happens to that negative? It disappears, and I get 4/9. Is everyone okay? Looks scary, but isn't, because you already know how to do it, right? Don't let looks fool you. Okay, you guys do 3. Looks weird, but is it? What do you notice about that, and that? They're the same base. So, is it just a regular math question? Even though it looks weird? Yesterday I would have given you this question. It would have looked like this. X cubed, x4 over x to the -2. And everybody could have done it. Now I put in numbers. Does it change? No. What do I do with the exponents? Add them. 1.4 to the 7th over 1.4 to the negative 2. What do I do with the exponents? Subtract them. What's 7 minus negative 2? To the 9th. So it would be 1.4 to the 9th. And I stop there because I'm only simplifying, right? Is number 4 scary? What do you notice about that, and that? Same base, so what are the rules? We already know them, don't we? What should I do on the bottom with those two exponents? Add them. I got 1/3 and 5/3. How many thirds is that? 6/3. What, isn't that 2? So I have 7, dummy head. I have 7 to the 2/3 over 7 squared. Yes? What do I notice about that and that? So what do I do with the exponents? Subtract them. So I need to do, I know it's going to be 7. Then I need to do some math. What's 2/3 minus 2? It's going to be positive or negative? This is a little tough. Negative, and then you already had the fraction, right? What is it? Negative 4/3. Can I leave it like that? Is that the right answer? As soon as the thirds comes up. Because it's got to do its frozen not responding thing first. There it is. Can I leave it like that? Is that okay? What's wrong with that? Negative exponent. So I've got to fix it at least to this. Can I leave it like that? I can. Is there another way I could write it, Jazkira? Can I do something with that fractional exponent if my teacher asked me to? Yeah, I could also do 1 over cubed root of 7 to the 4th. They're the exact same thing. Do I ever care? No. If I cared, what would I do? I would put it in the instructions. Does everybody understand? If I said in the instructions, I want this in radical form, you would give me that. If I say I wanted an exponent form, you would give me that. If I said I didn't care, what would you write? Whichever one you were comfortable with. Cool? Okay, turn the page over. Easy peasy lemon squeezy. What do I do with the x's? Add them. X to the 3 plus 2. What do I do with the y's? Add them. Y to the 2 plus negative 4. X to the 5th, y to the negative 2. Is that okay? Why not, Megan? I got a negative exponent there. What moves, the x or the y? Just the y. X to the 5th over y to the 2. Right? What do I have over here? What do I really have? I have 10 over 5, a5 over a3, and b3 over b to the negative 2. Split them into groups, and it becomes super easy. What's 10 divided by 5? 2. What do I do with those exponents? Subtract 5 minus 3, a squared. What do I do with those exponents? Subtract 3 minus 2 is what? 5. B to the 5th. Any negative exponents there? So do I have to move anything? So the final answer is 2a squared b5. Right? All done in our heads, no problem. Yeah? What about the next one? Oh, looks weird. Does anything change? Nope. What happens over brackets? Multiply. Negative 3 times negative 5. What's that? Positive 15. 1.5 to the 15th over 1.5 to the 5th. Now what? Subtract. 15 minus 5. 1.5 to the what? 10th. Easy peasy lemon squeezy. All in our heads, no problem. What's weird over here? A rational exponent. Is the 8 part of the base? So what do we know about that exponent? Where does it go? Everywhere. So when it gets to the 8, I'm going to have 8 to the 1/3, aren't I? And when it gets to the a, I'm going to have a. What's 3 times 1/3? 1. I've got a to the 1. And b to the what? 6 over 3, which is the same as 2, correct? 8 to the 1/3. Hey, I know what to do with rational exponents. That's the cube root of 8, isn't it? What is it? 2. A to the 1. I don't write a to the 1. I am not in grade 4. What is it? A and b squared. Is that a positive number? So does it stay there? Easy peasy lemon squeezy, right? Oh, barf. What do I do with 9? Because it puts it all together. 9 looks a lot like 6, doesn't it? So what should I do? Split it up. 4 over 2. A to the negative 2 over a squared. B to the 2/3 over b to the 1/3. What's 4 divided by 2? 2. What's negative 2 minus 2? A to the negative 4. 2/3 minus 1/3. B to the 1/3. Any of that negative? Oops. Yeah, what moves? 2b to the 1/3 over a to the 4th. Can I leave it like that? Yes, I can. What if my teacher says, I don't want any rational exponents? I want all my exponents to be whole numbers. So what should I do? 2 to the cubed root of what? B to the first power. Would I ever write a first power? Nope. Over a to the 4th. And finally, number 10. Whoa. I have lots of options for number 10. Without doing it, everyone's going to do it. But without doing it, would anybody like to volunteer what their first step would be? I'm just interested. Luke, what would you do first? You're going to get rid of that. That's absolutely perfectly fine. Works fine for everybody. Half goes to everything. So he would just do that. Is there another thing somebody could do first? Does anybody have another approach? What did we do in number 6 and number 9? We split it up. Could we do that in here? Could I do 100 over 25, a over a to the 5th, and no b over b to the negative 1/2? Could I do that? That would have been okay too, yes? All right, so everybody try number 10 on your own, because after that I'm shutting up. I'm going to finish this up doing both methods, and that's going to be where the video ends. After this, you guys are going to work on 16, 17, and 18. That's your work for the day and tonight, okay? I'm going to do both. The video is going to end with both of these. I'm going to do Luke's version in blue, and I'm going to do the other way in red. I'm going to do the other version in red, and then I'm going to call everybody's attention back up to the front and make sure everybody understands both. Alrighty. Was everybody able to do 10 in one of the two methods? Doesn't matter which one you use. When I approach an exponents question, I use whichever one works better at the time. So when I looked at this, I right away said to myself, hey, 25 divides by, or 100 divides by 25. So I use the red method for this question. But if it didn't, then I would use the blue method. Does everybody understand? When you have practiced enough, you can pick and choose. But right now, if you have one method that works for you, what should you do? Stick with it. Everybody good? Okay, I'm going to shut up. When you get onto page 15, please notice I did something a little weird to you for that first question. I asked you to evaluate it, which means you're going to simplify first, and then you're going to actually put in numbers and get a number for me. Okay? Okay. And then you're going to do 16 and 17, and that's homework. Did I say 18 too? Okay, do that. So that was 15 to 18 for you guys. And I can stop recording.